Wait a minute. I will set. Accept. FEM Class 19. Where is the red color? Where is clear? Red. Red color. One minute. Color problem, usual. The caps gets interchanged. Then I can't make out which color is which one. Red color, please. First I will set the board. Wait for my. Okay, visible. Here. No. Okay. Start now. His voice is fully clear. Voice fully clear. Voice fully clear. First, okay, I start now. I write here up to where I can see. Okay. See, one small explanation for you. Previous class was, I sent class number 19, correct? Yes or no? The previous class was class number 19 because 18 was the live class. 18 was live class. Live. 19 I sent today. Sent today. I told why sent? Because homework questions. Paper I can write, but here at least you can hear the voice. Okay, then 20th class, see today's class I did left side fixed right overhang. See last time question if you compare, this is very very simple. This I explained. Next tomorrow I will send you left right side fixed and left overhang. 20. Then 21, 22 is full homework. I will set so many questions and will not explain anything. I will come here, write a question in front of you only, write the answer. I will set in front of you, sorry, it's not live, recorded, no in front. I will write the answer. But you can make out, I want to prepare the answer. Once I write the question, some tricks are there, I will write the answer. That way, I will give around 8-10 homework questions, clear? That's why I reserved 21, 22. I reserved 21, so that 23 today is 23, correct? Today is 23. I told today 23 or not? Today I took 23 now, right now this class. Did I write 23? First. Did I write it as 23? First comment. 23 onwards, I am studying new chapter, so that when you study later, sequence will be maintained. So 9, 20, 21, 22 pending. Tomorrow or day after tomorrow, it will come for you. Okay, start. Now, new part. Be careful. Heading: analysis of pin-jointed plane frames. Pin-jointed plane frames. Frames by FEM, or what you call trusses. Trusses. Now, some most important part is there. See, when you consider beam, actually today's question will not be over today. I have to explain so many things. Slowly I will explain. And once this class is over, then same thing I will do. I will upload some extra classes for you, so that you can work out. Nothing new. If anything is there, I will tell in the class. See, in beam problem, see, ordinary beam problem, we consider bending. So, vertical forces and couples will cause bending. Therefore, displacement considered are V and theta. Correct? This theta is what? This theta is not your angle theta. Theta is deformation, slope. See, that elastic curve tangent, this theta is deformation. This is vertical displacement. And you consider what? Horizontal forces you are not considering. So you are not considering. U is not considered for beams. For beams, unknown displacements are, I write here now, see, for beams, we consider, be careful, red color. For beams, we consider vertical displacement and theta. This is vertical displacement, remember, vertical displacement, or people usually called what? Deflection. Deflection, or theta means angular displacement. It is not your 30 degree, 40 degree. Angular displacement, that is rotation. It will come in radians. Both of them will be strain effect is there. Both are unwanted. Why? More bending, no rotation means beam is getting more strains. Okay, now, this is for beams. Consider pin-jointed frames. Pin-jointed frames. Pin-jointed frames. Plane frames, see, like this. Pin joint, roof truss or bridge truss, etc. This way. Here, loads are acting here. Some loads are acting here. Okay. Even horizontal load may be there. Okay. Here, in pin jointed frame, there is all members. See, here, effect of these two is shearing force and bending moment. So, the section force for beams are shearing force, bending moment. For pin jointed frame, tell me the effect. Tell me section force effect. Which one? For pin jointed plane frames, there is no shear force, no bending moment. Tell me section force effect. Which one? Pin jointed plane frame, what is the section force effect? Answer. What is the section force effect? Compression or tension, or technical name is called axial force. It is called axial force. Axial force, it can be compression or tension. Therefore, here there is no rotation, that there is no angular displacement. No angular displacement. considered, or theta is not unknown. See, there is no slope and deflection here, over. But remember, here deformation is, which one, tell me? Deformation to be considered is u and v. Tell me, what is u and v? Some member will axially get compressed here. This will get axial deformation. See, this member, deformation is horizontal. This member, deformation is vertical. This member, deformation is along the member. If it is along the member, it has got vertical component and horizontal component. Or pin jointed plane frames, vertical forces, vertical and horizontal forces considered. See, beams, vertical force and couples here. Vertical force horizontal. Therefore, deformation or displacement considered are u and v. Clear? Theta will not come here. But remember, here theta will come. Right? Theta will come. That theta is not angular displacement. It is not angular displacement or strain. That theta is what? Tell me. What is that theta? Tell me here. In beam and beams, theta means rotation. See, bending is there. Here that theta is what? What is the theta which comes here? It is not a deformation theta. It is what? What is that theta you get here? It is not deformation. It is what? Fast. What is that theta you get here? I told earlier. Think of it and tell me. What is that theta you get here? You are delaying a lot. If you don't know, tell don't know. You should do one thing. Don't know means I will tell immediately. I won't wait. But I want the answer if possible. Angle. The theta is angle of inclination. Inclination. See, if I keep a member this way, theta is 0. No strain. If I put this way, theta is 90 degrees. If I turn here, theta is some 60 degree, 30 degree. It is not deformation. Or in pin jointed frame, whatever theta you get is, personal note, I should not tell, it is high school angle. Nowadays, not high school, nowadays primary school, correct? Primary school people, they are knowing radian, they know the slope, deflection, etc. Primary school students, they know anything about deformation, theta. For them, theta means angle of inclination. Therefore, here theta is simply angle of inclination. It is not deformation. It will not come for displacement matrix. And when theta is angular displacement, it should be in radians. But this theta in our class, you can take theta in what? Tell me. There is no need of radian. In the truss problem, when you are not bothered about angular displacement, then that theta can be in what? You need not worry about radian. That theta will be in what? High school angle. How high school people define angle? They don't tell radians all. High school, primary school. They don't use the word radians, etc. What they tell? What they tell angle in? High school, primary school, etc. They call the angle in what? First. What unit they tell for angle? Degrees. So here theta will be in degrees. And sin and cos, take calculator in degree mode. Clear? So therefore, in pin jointed frame, for displacement point of view, only which one? Only u and v considered. Okay, now before starting first, see there. If there is a hinged support is there, see, hinged support, it has got neither vertical displacement nor horizontal displacement. It can give vertical reaction and horizontal reaction. Reaction comes to prevent the displacement. Hinge. Actually here the fixed word is not there. There is no word called fixed. If the question fixed given, it is same as hinge only, no effect. Now, this is clear. For a hinge, see, hinge cannot move. Hinge cannot move, it can rotate. Rotation, we are not bothered. Then, if it is a roller support, see, roller support this way, then tell me here, there will be displacement how? Horizontal displacement or vertical? If this type of roller given, what displacement? Horizontal or vertical displacement? If this type of roller given, what type of displacement? If support roller given this way, what type of displacement? First. You have to comment little fast, should not waste. Some will tell you are knowing, sir, I knowing, but I want the response. If a roller is given that way, what type of displacement? It has got horizontal displacement. So for this one, see, there will be vertical reaction here. So vertical displacement equal to 0, but horizontal displacement is there. And by chance, if the roller is given like this, tell me, sometime you get some member fixed to the wall, then there will be horizontal reaction then. Tell me here. Here, horizontal displacement will be 0, but vertical displacement is there. Is there. Clear? Roller, you see how the roller can move, only that displacement. Perpendicular to roller, no displacement. Tell me clear or not? First. Tell me clear or not? If you tell clear, I will go to the next step. This question will take 2 classes. Slowly we will do. Then lastly, see, one more case, unsupported joint. Unsupported joint. Like, see, suppose a truss is given like this. This way, okay. This joint, unsupported joint. It can move horizontally, it can move vertically. So, horizontal displacement, vertical displacement, both are there. So, lastly, conclusion, in a box, right, fixed support is not there here. Okay, fix or hinge, both are same. No displacement. But in the beam problem, hinge means theta is there. Here, fix or hinge, no displacement. Roller, only displacement along the plane of the roller, no perpendicular displacement. Unsupported joint, where there is no support, horizontal displacement is there and also vertical displacement is there. Put in a box. Clear? If clear, I will start the first question. Clear? Okay. Now, step by step, I will give procedure for you how to solve the question. See, one more thing. You cannot do big frames in class. Why? For that, software is there. See, in the software, those who are coming to ETAP batch, remember, little later in the ETAP, I will prepare a truss of this type. Huge truss. Then, by method of joint or method of section, in the class, briefly, I will tell you how to find forces in the member. Just to give knowledge. Then, I will prepare the model and solve. If you solve by stiffness method, there are 16 displacements here. So you cannot solve. Then, once it is over, modeling is over, your ETAPs will give force in each member. Before that, in the class, we will get the forces by structural knowledge. Compare. Exactly same answer will come. That is, big frame solve, you analyze by software. Here you learn the principle of FEM, that's all. Here learning is principle. That is, even beams also. See, continuous beam, 8-9 spans. How you can do it? Not possible. There is a limit for solving in class. Class is always simple question. See, now, I will start the question here. Tomorrow's class, the question will continue. See, question is question number 1. Once the question number 1 is over, I will upload 2-3 classes there. Say, I will explain in the class those questions. See, find forces, find axial forces in all members for the given pin jointed frame. For the given pin jointed frame, I will take the frame here, see, this way and this way. See, this way. Now, one of the support I will take hinge here, other I will take roller here. This span 6 meter, where I will take this span I will take 10 meter. Then this distance I will take 6 meter, and the height I will take 3 meter. This is the question. Load, I will give an inclined load deliberately here. Why? So that you will learn something. Say 60 kilonewton, which makes an angle of 60 beta, 50 kilonewton. Okay, 50 kilonewton, which makes an angle of 60 degrees with horizontal. Okay, no, leave it. Which makes an angle of, I'll do one thing, 30 degrees with vertical, deliberately 30. And also this roller, I can give a force this way, right side force. I'll give a right side force for the roller here, that is around 10 kilonewton. This is the question, and in the question I will give you for this member area equal to 8 centimeter square. For this member area equal to 10 centimeter square, 10 beta, on the AE by L, okay, 8. For this member area is 6, 8 saladilla, okay. I will put 20 centimeter square. For this member area equal to, I will put 16 centimeter square. For this member I will give area equal to 30 centimeter square. Okay, and then in the question I will give E for the material is 200 GPa. This is a question. See, to find the force in the member, I need only half minute for this one. But you need 2 classes. Question clear? Question clear? I will give step by step procedure. Okay, now, first step. Before you start the question, first step is get length and angle theta for all members. All members. For all members. In beginning, angle theta means actually angle of inclination. Alright, one thing. The length and angle of inclination. Inclination, don't call theta. For all members, in degrees, all members, all inclined members, all members, okay. And in the beginning, when you start, get with horizontal. Get with nearest horizontal. Nearest horizontal. I will tell you what is nearest horizontal. If member is this way, get this angle. If member is this way, get this angle. Later, there is unique way of theta. Okay, start first. Also get AE. See, in beams it is EI. Remember, when bending is there, EI considered. In axial force, AE considered. AE, if data given. If data given. If data is not given, no problem. There, you solve in terms of EI. Here you solve in terms of AE. Okay, now start one by one. See, first trigonometry. This is the member given. A, B, C. No, this I will call A, this I will call B, this I will call C. This is A, B, C. Okay, right here. This is C. Vertical line is given. This height is 3 meter. This baseline is how much? 6 meter as per the question. This is 4 meter. This is A, this is B, this is C. I will call no theta. This angle, nearest horizontal, I will call alpha. This angle, I will call beta. I will call alpha and beta for this one. Tell me answer. See, now this is 3 meter. You can tell length of AC equal to square root of 6 square plus 3 square. Correct? 6 square plus 3 square root will give length of AC. I want the answer up to third decimal. Tell the answer. Root of 6 square plus 3 square will give length of AC. Fast. 6 square plus 3 square. Don't waste time. Is it 6.7082? Okay, 4 decimal. Is it 6.7082 meter? Tell fast. And remember, we will solve the problem. Solution will be in kilonewton and meter. You be careful. This is also important. Units like beam problem, solving is in kilonewton meter. Okay, now. Also get length of AB is not required because 10 meter you can see here. Length of BC equal to root of 4 square plus 3 square, 5 meter. Okay. Then tan alpha equal to 3 divided by 6. Therefore, your alpha equal to, this time degree will do, 26.565 degrees. 565 degrees. And tan beta equal to 3 by 4. See, 3 by 4. So beta will be 3 by 4. Shift tan inverse answer. 36.87 degrees. 870 degrees. Okay. Now, 1 minute. Length and angle over. Before you proceed further, consider one of the member, AC. Consider AC member. For AC member, they told cross-sectional area. This is A, point A. This is area of cross-section. They told 20 centimeter square. Convert to meter square. 20 centimeter square. Convert to meter square. How much? Oh, something happened there. I don't know what happened. Did I? Okay, no, luckily. Got the shock because I had made the calls. Okay. I got a shock because if a call comes in Zoom, nothing to worry. By chance you forgotten, you can reset immediately. In YouTube, not that way. No resetting. I should be extremely careful of YouTube. If a disturbance comes there, gone. The class has to close and restart. Some sound came. I thought maybe it came this mobile, I think. Oh, it is coming. Preetham joined Truecaller chat. Okay. Say hi to him. Okay, hi. You joined Truecaller chat. It is coming here. Okay. So area in centimeter square or equal to 20 into centimeter to meter 10 to the power minus 2. Okay, then square is there, you square meter square. And your E equal to 200 GPa or equal to 200 into 10 to the power 3 MPa. MPa means Newton per mm square. Now do one thing, go further. Or equal to 200 10 to the power 3 Newton per mm square, convert to kilonewton per meter square. How to convert it? Newton to, you want in kilonewton per meter square we want. Numerator, Newton to kilonewton into 10 to the power minus 3. Divide by mm square to meter square 10 to the power minus 3 whole square. Correct? Whole square. This is the value of E. Sufficient to be. Or tell the answer. It is how much? Or you can tell here, this is 20 10 to the power minus 4 meter square. This is 200 into, this will cancel, this will go to numerator, 10 to the power 6 kilonewton per meter square. Therefore, for member AC, your AE equal to how much? Area 20 10 to the power minus 4. that is in meter square into E is 200 10 to the power 6, that is in kilonewton per meter square, or AE answer for B equal to, tell me answer now. It is 200 into 20. What is the answer? Answer. I want AE value for this number. 20 10 to the power minus 4 into 200 10 to the power 6 is it divided by 10 to the power 3? Is it 400 10 to the power 3? Is it 400 10 to the power 3? 400 into 10 to the power 3. What? See, meter square, this is meter square. Kn per meter square, it comes in Kn. Remember, EI comes in Kn meter square, AE comes only in Kn. Why? Meter square cancels. This step is clear? Fast. Okay, now do one thing. Do not waste time. For BC member, tell directly AE equal to. See, instead of 20, change it to 16. Don't waste. Divide by 20, multiply by 16. Don't waste time. If 20 centimeter square become 400, tell me how much 16 centimeter square will become. Don't number. Don't calculate all these things. Once you do efficient, how much number will come? If 20 centimeter square area became how much? 400, that 60 will become what? What? If the 20 centimeter square finally changed over to 400 10 to the power 3, that 16 will change over to. Simple mathematics. It will simply change over to this much time. 320. Don't waste time. 320 10 to the power 3 kilonewton. And for AB member, 20 became what? 400. Tell me what it will become? AE member. AE equal to. For this member, 30 centimeter square, believe it, into 400, 600 10 to the power 3 kilonewton. Fully clear? Tell me fast. Is the procedure fully clear or not? This question will take 2 days. Usually when I do offline class, the first question takes 3 or 4 hours. So that everything will be told. Okay, now what you do is now before you go further, right, so now AE problem is over. Angle for all members are over. Next, loading. When you consider the load matrix, there load should be either horizontal or vertical. Here one inclined load given. So what you do? Next will be, if any inclined load given, resolve into component. Nodi, at the point C, there is an inclined load given here. How much? 50 kilonewton. Angle it makes with the vertical is 30 degrees. But when you resolve, it is always better to consider angle with horizontal. So you don't use it. This angle with horizontal is 60 degrees. Then this will be equal to, see, if I resolve, this will have a horizontally left component and vertically down component. See here, horizontally left component, vertically down. Horizontal component is 50 into cos of the angle with horizontal. This is 50 into sin 60. 50 cos 60 is undoubtedly 25 kilonewton. 50 sin 60, what is the answer? 50 sin 60, what is the answer? 50 into sin 60, this you are supposed to know. 50 into sin 60. Is it 43.30? Is it 43.301? If it is 43.01, I write only 43.3, I write 3 kilonewton. 01 not required, leave it. Fast. I don't know. See, you are not telling answers all today. 50 into sin 60. Yes, 43.301. That one I will leave. I will put 3. Okay. Now, to understand the question, once again write a sketch. Okay. This sketch I will remove. See, this sketch I am going to remove now. What I am doing now is, see, I will write the question with everything in kilonewton and meter. And see, the truss is like this. It is this way, and this way. Okay, leave it. There is a vertical load here downwards of 43.3 kilonewton and a horizontal force to left side here of 25 kilonewton. This is a hinged support. This is a roller support. And then for this member, your AE equal to, how much answer you told? What is answer AE? 200, A equal to 400. For this member, your AE equal to 400 10 to the power 3 kilonewton, and length of this member is, where is length? Length of that member, okay, 6.7082 meter. For this member, your AE equal to 320 10 to the power 3 kilonewton, and length of this member is 5 meter. For this member, now this line is not there. That construction line is not there now. AE equal to 600 10 to the power 3 kilonewton, and length of that member is 10 meter. And there is this is A, this is B, this is C. There is a one inclined member with the nearest horizontal. This angle is, oh, I remove the angle. Anybody can tell that angle? I forgot that angle now. Ayyo, that angle, I forgot it now. I removed it. That angle, that is 3/6. Shift tan inverse 0.5. 26.565 degrees. 26.565 degrees. This is 26.565 degrees. This angle with nearest horizontal is 36.87 degrees. This is the question we are solving by finite element method and analyzing for all joint displacement and also member forces you are finding. That is the principle of finite element method, how to analyze a pin jointed frame you are starting. Full clear? All the procedure so far. I will not repeat for each and every class. See, next class I will upload what? Recorded class. Homework I will upload recorded. Why? Instead of giving notes all this one, recorded means what happens? Some point I will explain here so that you can understand. I will upload all recorded classes as homework. But main class is live. You are not answering. This much is fully clear. So many, today very less strength. Clear. Okay. Now, next step is, first remember, nodes are considered where? Nodes are considered at only joints here. Nodes at A, B and C. That is one node here, one node here, one node here. A, B, C. This is the nodes. Okay. Then write what is degree of freedom. Delta, degree of freedom equal to, see, what you do is correct order you start. Make a note. Those who want to make a note. See, start from A. At A is a hinged support. See, you can write here. Vertical displacement equal to 0. Horizontal also 0 at A. At C, C is unsupported point. Therefore, at C, vertical displacement is there. Always remember first horizontal, not vertical. In this method, first horizontal. Horizontal displacement is 0, vertical is 0. Here, horizontal displacement is there, vertical displacement is there. B is a roller. Next class I will give hinge here. If I give hinge here, both are 0. Homework. Horizontal displacement is there. This B can horizontally move. It cannot move vertically. Vertical equal to 0. So your degree of freedom is 3. If you start in an order, start from here. Anyone first. It is U at C, comma, first U. Always first U, then V. V at C. That's all if they give hinge support here. And also U at B, UB. UB is not that UB you get in the shop. UB. Now write a what? coordinates in direction of degree of freedom. You write the coordinates in direction of degree of freedom. See, this is coordinates in direction of degree of freedom. In the same order, U is always right side in a PM. Remember, V is always upward in a PM. Again, U is there, right side. U at C is coordinate number 1. Vertical at C is coordinate number 2. Then horizontal at B is coordinate number 3. This is coordinates in direction of degree of freedom. Last step, I will sit and write displacement matrix. Displacement matrix. First question. See, this question I am writing everything. Displacement matrix with respect to degree of freedom, that is delta matrix, equal to, in correct order, see which one first. U at C, horizontal at C, vertical at C, and horizontal at B are the displacement. This is coordinate 1, coordinate 2, coordinate 3. This is right side, this is upward, this is right side. This is same as beam problem. This much fully clear means I will go to next step. Systematically you will solve. This much fully clear means I will go to next step. If this much is fully clear, I will go to next step now. See, when I take any new chapter, first time when I solve, I will tell each and everything so that class will become lengthy. Yes, if you spend a lengthy class with full explanation, then only you can understand thoroughly later. Okay. Now, I will tell one thing. By the time we reach tomorrow, this sketch will not be there. So, tomorrow, when we write force matrix, there 6 columns are there. In the correct order will be, I will start from A. First is a very important. What order you maintain is there. I will go for first A. In the order will be UA, VA, UC. After A, I am going to C. That will be UC. Any order you can go. UC, VC, UB, VB. Tomorrow's class, UA right side, VA upward, UC right side, VC upward, UB right side, VB upward. Tell me now, see, UA is not required because by degree of freedom, UA is 0, VA also is 0, and VB also 0. So tell me, tomorrow, what force I will enter with respect to U at C? Tell the answer. Because this sketch, once again, I am not writing. See the sketch and tell me. Horizontal displacement at C, corresponding right side force. See the sketch and tell me what value I have to enter. See the sketch and tell me. I am removing the sketch now. See that sketch and tell me tomorrow when I enter force matrix for UC. UC is right side. Remember, in FEM, every U is right side. Tell me, I will enter minus 25 there. And tell me, what VC I will enter? Force at C is 43.3 down. Tell me, what VC I will enter tomorrow? I will take a photo of the sketch. A photo I will take today. Because I am removing this one. Tomorrow I will not explain once again. What VC I will enter? Minus 43.3. 43.3. And tell me what VB I will enter tomorrow. What VB? UB. Horizontal displacement to right side. Oh, sorry. There's one. Oh, I forgot. A force is given here. How much? Tell me. I forgot. Some force are given. Anybody can tell what force is given there? I forgot that force. Who remember now? 10 kilonewton. Thank you. 10 kilonewton. Okay. Therefore, tomorrow for horizontal at B, tell my entry here. tomorrow. I will not tell, I will tell already explained yesterday. Plus 10 or minus 10? Plus 10. Is it fully clear tomorrow? This is for tomorrow, Ivattalla. Tomorrow's class. Because we won't reach there today. Today we won't reach there. Tomorrow question will be over. So that Saturday, Sunday you can practice. Clear? Okay. Now, always next step is, see, write element matrix. See, right here. This is standard. I will write today in the blue color. From today onwards, I will not write this one. This is, see, once for all settlement. Means in future I am not going to write this one. Remember, in future I will not write this statement. This is permanent for pin jointed frame. Pin jointed frame. This is permanent for pin jointed frame. Start. Consider member ij with the nodes at both ends. Nodes at both ends. Both as shown. As shown. Very, 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 very important. Ij, therefore, it's a personal note. Exam don't write. Personal note. Therefore, tell me the starting point. When I tell Ij, tell me the starting point. Very, very, if you call AC or CA, it completely changes. You call it AC and enter for CA, problem is gone. When I tell Ij, starting point, which is starting point? Starting point. I call Ij. What is the starting point? This much difficulty to tell Ij starting point. This is beyond the limit waiting. I will not explain once again. Everything go through today's class 100 times. Starting point is I. So I will write important Ij. You are important, and therefore remember angle measured at starting point. At starting point, therefore at I, not J. Clear? Your angle should be measured at I. And one more thing, angle should be, angle is called theta. It will be, or it should be in anti-clockwise direction. Very important. With positive x direction. I will not tell once again where is the starting point. At that point, angle made by the member in anti-clockwise direction with the positive x direction. That means if this is a starting point here, if member is this way, this is called positive x, this angle. If member is this way, this angle. If member is this way, this angle. If member is this way, not this angle, this angle. You should measure the angle. See, starting point here. This is the way to measure the angle. One full round. 100% clear. Will not tell once again. 100% clear me, tell me. Will not tell once again. Angle measured at starting point, very important, and then it should be measured in anti-clockwise direction with the positive x direction. You are not telling clear or not? You are not telling clear or not? Angle should be clear. Okay. Therefore, now start. This all over now. Your element will be always like this. This is the joint I. This is J. Displacements are, this is UI, this is VI, this is UJ, this is VJ. L and AE. Angle should be like this. Ready? This is the positive X. Now, element stiffness matrix. Element stiffness matrix for IJ. For IJ, starting is I. That is called KI. I is important. I is more IJ. That is K for IJ. I is very important. IJ. IJ equal to, if you remember, it is AE by L times. Do you remember the derivation done in the class? Tell me. Do you remember how is the order? Order is I first. UI, VI, UJ, VJ, UI, VI, UJ and VJ. See, be careful. U and V. U is like this, V is like this. Both looks like same. See, V, you can see a curvature there. See, lambda square, lambda mu, mu square. Then, hey, go there. Lambda square, lambda mu, mu square. You go that side, change the sign. Minus lambda square, minus lambda mu. Go that side. Minus lambda mu, minus mu square. You come this side. Minus lambda square. Come this side. Come. Minus mu square, minus lambda mu, minus mu square. Where lambda is cos theta and mu is sin theta. Tell me, do you remember or forgot? How to remember all this I told? Now onwards, in my class, I am not telling anything about this one. Clear? Fast. Clear or not? Clear. Okay. Now, you write a sketch. See, very important. Write sketch. Okay. I'll remove this one now. This statement should come. Every question briefly. This story all not required. Now, you see, note, consider all the member. One member only once. Start. Consider AC. Consider AC. If you are measuring angle at A, it should be considered AC. Suppose you want angle at C, tell me how to write it. Suppose you are interested to write angle at C, then how to write it? It is not AC then. How? In case you want to measure the angle at C, you can still, no problem. You can write either AC or CA. But if your angle at A is considered, call AC. If you are interested in angle at C, how to call it? You should call it CA. So when I consider AC, any member, see there is no rule. There are three members here. You call either AC or CA. But once you call AC, be careful. AC, if you call, A is the starting point. Clear? Clear or not? A is the starting point. Okay, now, sketch the starting joint. Remember, always sketch the starting joint. Or I'll do one thing now. I'll write here. Consider joint A. You do one thing. Consider joint A. One by one joint you consider. Always first consider the joint where number of members are more. Okay. When you consider joint A, see, one member is here. This is A. This is B. One more member is here. That is C. So, since I consider joint A, this member I have to call AC. This member I have to call AB. See, this is positive X direction. For AB, no angle, angle is 0 degree. For AC, this is the angle that you should consider the angle in anti-clockwise direction. Oh, that is 26.565 degrees. Okay, over. Then after A, consider, okay, now when you consider joint A, see, this member is over, this member is over. Go to some other joint. Tell me, either B or C, anything will do. I will go to joint C. Anything, our choice, joint C. When you go to some other joint, consider only remaining members there. A member already considered earlier should not be considered once again. See, when you consider A joint, we considered AC and CB. When you go to joint C, don't consider CA. Why? AC is already over. A member should not be considered second time. So tell me, when I go to joint C, this is your positive X. See, only member is this member. Which member? Tell me. Only member. See why? Because you write here, this member, this, already over at joint A. Joint A. So only one member. You need this angle. See, this is 36.87 degrees. Anybody can tell me what is this angle? First, you should measure the angle made by the member at the starting point with the positive X in anti-clockwise direction. First, answer. What is that angle? Little high speed, don't waste time. I will continue further and stop now. Fast. That angle. Shall I come tomorrow for that angle? This much time for that angle. You are delaying a lot. 143. ಅಯ್ಯಯ್ಯೋ ಸರಿಯಾಗಿ ನೋಡಿ 143 ಅದು. This is 26.57. ಓ ನಿಮ್ಮ ಪ್ರಕಾರ ರೌಂಡ್ ಇಸ್ ಒಂದು ಫುಲ್ ರೌಂಡ್ ಇಸ್ 180 degrees ಫಾರ್ ಯು. ವಾಟ್ ಈಸ್ ದಿಸ್? ಯಾರು ಕೊಟ್ಟಿರೋದು? ವಾಟ್ ಈಸ್ ದಿಸ್? ವೆನ್ ದ್ಯಾಟ್ ಈಸ್ ವಿಚ್ ಆಂಗಲ್? ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ದಿಸ್. ಹೌ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್? 143 degrees. It is this full angle. ಅದು ಹೆಂಗದು 143? This one full round is 360 degrees. ಇದು ಹೇಳ್ಕೊಡ್ಬೇಕಾ? This also you want. Tell the angle. If you make a mistake in the angle, you will not get the answer. How you got 143? Which member? E member Allah. This member is not considered. I want for which one? C to B. CB member. If you don't tell the angle, I will stop the class. How it is 143.13? 323.13. Sadhya badukde. It is 323.13 degrees. Okay, now both this, now all members are over now. Tell me. All members are over. First tell me, yes or no? All members are over now or not? All members are over? No. All members over or not? Over. Now, tomorrow, see, therefore, I will tell you now only. I will not explain tomorrow. Tomorrow's class, tomorrow, one table is going to come. In the table, there will be theta. One of the theta there will be 26.565. Other theta tomorrow will be 323.13 degrees. At that time, I will ask you what is lambda. Okay. So that, see, tomorrow, one of the theta will be 0 degrees. Yadake AB member ke. Other theta will be what? 26.565 degrees. Another theta will come. Estadu 323.13 degrees. Then I will ask you what is lambda. Then I will ask you what is mu. Then I will ask you what is lambda square. I will ask you what is mu square. Then I will ask you what is lambda mu. If you tell now, I will prepare the table tomorrow to save the time. Okay, tell me, answer. There's a systematic way of writing. Tomorrow I will tell you. Tell the answer. For 0 degrees, lambda. Fast. For 0 degrees, lambda. Oh, don't waste time. Lambda means cos theta. Remember, lambda is always cos theta, mu is sin theta. Tell me, for 0 degrees, lambda. So, ಬೇಗ ಹೇಳಬೇಕು, ಟೈಮ್ ಇಲ್ಲ. You are wasting lot of time. For 0 degrees, lambda, cos 0. Tell the answer. I will not explain this step 1. Do one thing. Don't waste time. Now only square and write. Adu ಒಂದಾಯ್ತು. Tell me, mu 0. Mu square 0. Lambda mu 0. ಆಯ್ತು. Tell me, for 26.565 tomorrow, tell a lambda. Tomorrow, lambda. For 26.565, tomorrow, lambda. Tomorrow, because why? I am feeling tired also by now. Today, moment area method, it was a new concept. I shouted like anything. For you also, both the classes are new concept. New concept means too much of strain. So, I will complete this one. Tomorrow, I will tell you how to prepare the table. But value, I will write before the class. 0.894. Can you give me 4 decimal? For accuracy, can you give me 4 decimal? Because finally tomorrow I will tell what answer has to come. To solve this question and get the answer, I need only 10 to 15 seconds. I do not require this much time. In 10 to 15 seconds, I can give the answer for this question, which you struggled for 2 classes. Nearly what? Nearly more than 2.5 or 3 hours, 0.8944. Okay. Then, don't waste time now. Immediately square and tell me here. Lambda square, first. I will take a photo here and enter tomorrow. I will not explain tomorrow. Immediately square madi. This is how to do it. Don't go to mu. You square this one and tell me here. 4 decimal. Square this and tell me here. Square that and tell me here. Bega. You are wasting my time. Whatever lambda you got, square and tell me here. 0.8. Exact 0.8. And gotilla. 0.8. Now, what is mu? What is mu? Sin theta. Sin of 26.565. Begali. Sin theta. What is sin theta? 0.4472. Now only square it. Square madi. Square madi. Or tomorrow what I will do is, I will tell lambda square, then I will put lambda mu here, then I will put mu square. Better, hinge is better. So that idu 0, idu 0. Iga. Mu ಆಯಿತು. ಸೈ ಎಲ್ಲೋಯ್ತು ಈಗ? lambda ಆಯಿತು. mu 0.4. Tell the mu square. Tell me mu square now. 0.19 mu square. 0.19998 is 0.2. Correct? It is 0.2. Correct? See, cos square theta plus sin square theta is 1. And now only tell me lambda into mu. Right here. Lambda square right here. Mu square right there. Lambda mu right in between, so that you can fit it to matrix. Lambda into mu. Bega. 0.8947 into 0.4472. Number. 0.8944 into 0.4477. ಬೇಗ ಇಷ್ಟೊತ್ತಾಗುತ್ತಾ ಲ್ಯಾಂಬ್ಡಾ ಮ್ಯೂಗೆ? ಲ್ಯಾಂಬ್ಡಾ ಇಂಟು ಮ್ಯೂ. ಬೇಕು ನಿಧಾನ ಮಾಡ್ತಾ ಇರೋದು ನೀವು, ಸ್ವಲ್ಪ ತೊಂದರೆ ಕೊಡೋಣ ಇವರಿಗೆ ಅಂತ. ಲೆಟ್ ಹಿಮ್ ಸ್ಟ್ಯಾಂಡ್ ಫಾರ್ ಅವರ್ಸ್ ಟುಗೆದರ್ ಅಂತ. 0.4. ಓಕೆ 0.4. ಓಕೆ. ನೌ ಟೆಲ್ ಮಿ ಟುಮಾರೋ ಫಾರ್ ಥೀಟಾ ಈಕ್ವಲ್ ಟು 323.13 ವಾಟ್ ಈಸ್ ಲ್ಯಾಂಬ್ಡಾ? For 323.13, what is lambda? Sin cos of 323.13. ಬೇಗ ಹೇಳಿ ಆನ್ಸರ್. ನನಗೆ ಗೊತ್ತಾ ಆನ್ಸರ್ ಎಷ್ಟು ಅದು? 0.8 ಬರುತ್ತೆ. ನನಗೆ ಗೊತ್ತದು 0.8 ಅಂತ. ನೀನು ಹೇಳಬೇಕು. ಐ ನೋ ಇಟ್ ಇಟ್ ಇಸ್ 0.8. ಬಟ್ ಯು ಶುಡ್ ಟೆಲ್. ಯು ಶುಡ್ ಟೆಲ್ 0.8. ಓಕೆ. ಟೆಲ್ ವಾಟ್ ಈಸ್ ಮ್ಯೂ. mu. Lambda square, bari, ettu, 0.64. Aitu. What is mu? I know it is 0.6. Answer. I know it is 0.6. Answer. Good to ಯಾರುಗಳು ಬಡಿ. ನನಗೆ ಗೊತ್ತದು 3, 4, 5 ರೂಲ್ ಇದ್ದರೆ ಕಾಸು ರಾಂಗ್. ದಿಸ್ ಮಿಸ್ಟೇಕ್ will spoil your problem. See correctly. I told numerical value. ಅದು ಸೈನ್ ಆಫ್ 323.13 ಸರಿಯಾಗಿ ನೋಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಟ್ಟು ನೋಡಿ. ಯು ಒಂದು ಮೊನ್ನ ಮಿಸ್ಟೇಕ್ ಮಾಡಿಬಿಟ್ರೆ ಹೋಯ್ತು. ಕಂಪ್ಯೂಟರೈಸ್ಡ್ ಇಟ್ ಈಸ್ -0.6 ನೋಡಿ. ದಿಸ್ ವಿಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಥ್ರೋ ಯುವರ್ ಕ್ವಶನ್. ಮ್ಯೂ ಸ್ಕ್ವೇರ್ಗೆ ಮೈನಸ್ ಬರೋದಿಲ್ಲ, +0.36. ಓಕೆ ಎಲ್ಲ ಪಾಯಿಂಟ್. ಈಗ ಲಾಸ್ಟ್ಗೆ ಲ್ಯಾಂಬ್ಡಾ ಮ್ಯೂ. Lambda mu with sin I require. From next question onwards, this much I will not explain. ಅದಕ್ಕೆ ಹೇಳಿದ್ದು ನಾನು ರೆಕಾರ್ಡ್ ಮಾಡಿ ಕೊಡ್ತೀನಿ. ಐ ವಿಲ್ ರೆಕಾರ್ಡ್ ಆ್ಯಂಡ್ ಗಿವ್ ಯು -0.48. Okay, now tell me, when I give more questions, if I record the class when I am free and upload in YouTube, is it clear or not clear? Up to here. If I record the class up to here, any question, of course, I will explain degree of freedom once again there. I will explain once again. Can I record up to here and give any question homework now? Simply giving homework means you will not be knowing where is the mistake. If I record and upload, then if you got a mistake, you can check where is the mistake. Okay, thank you. Now, tomorrow, when I put the table, this value I will enter. I will take a photo later. I will take a photo. ಈಗ ತಗೋತೀವಿ ಬಿಡಿ ಫೋಟೋ, ಮರ್ತೋಗುತ್ತೆ ಆಮೇಲೆ. ಐ ವಿಲ್ ಟೇಕ್ ಎ ಫೋಟೋ ನಾವು. ಓಕೆ, ಬಿಡಿ ರಬ್ ಮಾಡೋದು. ಬಿಕಾಸ್ I will take later. Other mobile I will take. So this sketch also I will take a photo. Then I will tell how to assemble the stiffness matrix, and then how to find the displacement, and finally how to find member forces. Tomorrow this question will be completed, and I will give 2 or 3 homework tomorrow for you with no hint. Simple question. I will put hinge here and roller here. Then I will give a question where both are hinges. Can you solve all those one? Oh, I came out of YouTube. Can you solve all of them? Okay. We will meet tomorrow. Continue. Study. Tomorrow I will tell the class some changes are there. I will tell you there is a method called Rayleigh-Ritz method. Potential energy, etc. comes there. For MTech students, one question comes there. So I will take extra class there. And one more thing, I should finish for them before this month end. And second thing, for FEM knowledge, it is not all that important, but the concept is there. So I will take when they are free. Those who are not able to free, can you watch recorded version? Suppose you are not free in the afternoon time, their exam is nearing. I will upload. Can you see the recorded version? But in Zoom, it will not be in the YouTube, it will be Zoom. In the Zoom, recording I will send you. Not much effect. Why? Rayleigh-Ritz method is only a tribute or respect to Rayleigh, because of whom the FEM started, or inspiration, motivation came. But that principle is not used. But syllabus it is there. Syllabus, see, sometimes some methods they don't remove from syllabus. Like Clapeyron's 3-moment theorem. It is useless now. We got MDST-Carney's method. Why you want 3-moment theorem? Because that was the first method came before this MDST-Carney. So as a respect to Clapeyron, it is still maintained in the syllabus book. Okay, thank you. Tomorrow we'll meet.